Hello, I'm going to do another Leetcode question today. We're going to do an easy one and we'll choose one at random. So let's see what we get. Feel free to follow along. I'll have the link below for anyone who's interested. Today we get number 1748, sum of unique elements. I have a GDoc over here. I don't like using it, but sometimes you have to get practice with something that's not an IDE, and just because that's what you might have access to in an actual interview. Sometimes for the online tech interviews, they use a notepad of some sort or their own custom flavor of IDE that has different syntax highlighting than the one you're used to. So just kind of get used to not relying on your specific IDE. In fact, you can use a different one, not too important. In fact, I'm hoping to switch over to using an IDE for some of these questions later on. So we'll see how that goes. Back to the question though. Sum of unique elements. You're given an array of nums. The unique elements of an array are the sum elements that appear exactly once in the array. Return the sum of all the unique elements of nums. Okay, that's interesting. So it's not unique like repeats are allowed. So like normally when you do something like this, let's say if you were to take the array and get unique values, you could do say Python sets. That would give you 1, 2, 3, just like that. And then if you were to count that, that would give you 3 values. That's not what we want here. Unique means just one value exists. So in fact, the unique would just be 2. And that's my understanding of it so far. And we want to get the sum of all of them. So the sum equals, 6 in this case. That's not relevant though. We don't want that. We want the other one. So 1, 2, 3, 2, 3. 1, 2, 3, 2. 3 and 1 are both unique. 1 plus 3 is 4, gives us our 4. Okay. When none of them are unique, you get 0. And if all of them are unique, you just get the sum. The array is not sorted or anything special like that, so we have to check every single value. So the ideal algorithm has to check every single number for n numbers O of n time. The output's going to be the sum, so O of 1 space, ideally. One thing to keep in mind is edge case. If the sum is greater than the size of int, which is like 2 to the power 32. Oops, sorry about that. Do we have to worry about that? Since this is Leetcode, the answer is going to be no for the easy question. And in fact, here we know the length of the numbers is 100 and the maximum value is 100. So we're looking at something very, very safely under this limit, which I think is like 4 billion or something like that. The other edge case they kind of came across right here is what if there aren't any unique elements? So the sum is just 0 there. We're always going to get at least one number passed in. So we'll always have at least one value. And if there's just one, it'll definitely be unique and we're good to go. So I think we have enough information to kind of think about our approach. Approach 1. We'll iterate through the list. Let's actually just start writing our skeleton while we're at it. So sum of unique is the name they provided to us. And it'll be a list of ints. And our output will be a sum as well, which is just int. So we'll call that our total is 0. And eventually we return a total. And we're going to iterate over every value. So for num and nums. And if the number is unique somehow, check unique. I'm not actually writing this code. Then we add it to the total. So the question now becomes, how do you check if something is unique? It's not easy to do unless you go through the whole array. So you could have a whole separate function here. So first of all, think about it this way. O of n, if you were to have a check unique function for that num, one way you might do that is a function that check unique. I'm not actually going to do this, but the idea is iterate over whole list, count how many instances are there, return count equals 1. True if unique, false otherwise. So that's one way you could do this, but this would be a O of n type solution. And if you're doing O of n over O of n, you'd have a O of n squared. So we're already pretty inefficient at that point. So let's not do it the brute force way. The second approach is to think about, well, the one advantage here is with this brute force, actually, before we say no to that, is that you don't actually have to store anything besides the original array which are passed in, and you just are counting through all of them. So that's one approach. But let's say we wanted to do, O of n squared. Let's say we wanted better than that. The idea here is, as you probably already know, is a dictionary. And what we'll do is count each unique value and store in a dictionary. And you could actually do that. And here's where you can ask your interviewer if you're allowed to use existing standard libraries, because there's a thing called the from collections import counter, I think is what it's called. And you could do counter of the nums, and then you just want to get where those values are equal to, and what this will do is return basically a dictionary of the value and the number of the counts of it, and so on. So you could do something like this, and then you could say, like, let's copy our list over here, and you just create your counts. And this process is O of n to iterate through all the lists. And in the worst case, you're storing O of n values. And this is where we start to get we have to kind of start thinking about trade-offs. And here, for, I think it's value and key val in counts.items, just like a normal dictionary. If val equals 1, unique, and then total plus key. And then you just return your total. And this is one way to iterate through the whole list and do it just in O of n time. Checking each of those is totally fine. In fact, you don't even have to do gets. But if you did, it would still be O of 1. So if you're allowed to use a counter, you could do this, but more likely than not, you're not allowed to use a counter. Another question is, could you use a default dict? So let's just do that approach as well. And so let's say we're only allowed to use a default dict. So here the idea is we'll call our counts is equal to a default dict of int. The default is 0. And then for num in nums, counts of that num. And this gives us the exact same thing. And now we could use it the exact same way again, and we'd be good to go. And this is still O of n. Can you guys see this? Good, yeah. But let's say you're not allowed to use that either. Let's say you have to implement it all directly. So we'll just have our initial dictionary that's empty. And then what we'll do here is say count of num. If it doesn't exist, well, first of all, we'll just make it equal to +1 if it exists. If counts of num, or num in counts, else it's just 1 because it's the first time. And that way we don't even have to use a default dict. So let's start with that one and see how it goes. And actually, one more thing we can think about here is, can we do something that's a little bit more cleaner than, say, 3 levels in? And the answer again is also yes. So let's copy this over one more time, and we can always go back. The reason I'm copying it so many times is if I make a mistake, I can just go back and talk about it here. Space is free, more or less, so feel free to use it. So what I'd like to do here is make a inline. And in fact, we'll just keep the key. We get rid of our total. And here's where we check. And if you've seen this before, this is a generator right here. And you can iterate over this generator using a function like sum. You could even generate the list directly like this. That's list comprehension, I think it's called. But we don't even need to create the list. We can just run the sum while we're doing it and return that instead. And technically you could do it for this nums as well. So let's think about that for a second. I don't think I want to do that. I think it's a little cleaner to keep it separate like this, but this is still O of n. Well, technically O of number of unique numbers in the list, but in the worst case, O of n. We have our O of n, and we're good to go. So yeah, I think we have a working potential solution here. We don't have to worry about empty lists. If it was empty, both of these would actually be 0, and we'd return 0. Pardon me. So let's see what we get. Let's copy it over. We're about 10 minutes 30 in, and it looks like our nums is the same. That's good to see. All right. So before we run it, let's just think about some of our test cases. We had the ones they showed us here, and in fact, they're down here. So here we should expect to build accounts, and this will be our O of n space. So what we'd expect to see for this one, after this list is through, is that counts is equal to 1:1, 2:2, and 3:1. And then when we iterate over this list here, we'd expect it to only sum where the value is equal to 1. So that's where it's 1 and 3. So basically we'd get the sum of one, 3. Which is what we would expect to see in this case, as you can see in that example there. When they're all 1s, the count would be 1:4, and this one, everyone's unique, they'll all be 1s. Okay, so I feel pretty good about that. Can't think of any other edge cases off the top of my head. If you guys can think of any and are yelling out loud, sorry about that, but hopefully this runs. Let's find out. And it passed the test cases. That's great to see. Let's submit it. And it passed. That's awesome. I wouldn't worry too much about the time. For problems this small, usually this bell curve is kind of just a function of the backend system running it on Leetcode servers and less to do with the formula. Might not be the case here, but I think it usually is, unless it's a problem that has multiple algorithmic solutions that are somewhat equal in big O, but in implementation slightly different. I'm trying to think of any other shortcuts we could do here. So of course the ones we talked about here, I bet, is if we use count. So the reason we're not using collections was just arbitrary, used by the interviewer. Uses C in the backend, so probably faster by far. So let's actually just see if we can copy it over and have a look at that while we're at it. That'll be this one right here. And then we'll just remove that and do it like that. And I think that's all we need to do. So let's just run it on our test case again. And it passed. And let's just do our submit. Yep, and it ran. And now it's a little bit faster as we hoped. So, okay, I take it back. The bell curve has maybe a little bit of an impact based on whether it's using an existing C backend type approach for even something as simple as this. But don't worry about this too much, because technically these are equivalent to Big O. This is more of an implementation type optimization than algorithmic, which is usually not the intent for entry-level interviews if that's why you're looking at this Leetcode Easy. So yeah, all right, well, hopefully this was interesting to you all, and see you guys next time.